Hey guys, in this video we are going to discuss about the carboxylic acid. So carbon compounds contain carboxyl functional group, or call it as your carbon compound contain carboxyl group COH, or call it as a carboxylic acid. The carboxyl group consists of carbonyl group attached to hydroxyl carbon, hence name carboxylic acid. So here this is your carbonyl group, this is attached with your hydroxyl group, so then your carbonyl plus hydroxyl, we call it as a carboxyl. Clear? So this is hydroxyl, this is your carbonyl. Clear? Then we go for the your alkyl or aryl attached with your carboxylic carbon. Then we call it as a aliphatic and aromatic acid. So large number of carboxylic acid found in nature, some higher members of all carboxylic acid. If it your carboxylic acid in that carboxylic acid in which the carbon number is 12 to 18 carbon, then we call it as a fatty acid. So occur in nature, fat esters of glycerol, carboxylic acid serve as a starting material for the preparation of anhydride, ester and acid chloride and amide, right? So next we are going to discuss about the nomenclature of carboxylic acid. We know that, right? Actually the common name derived from your Latin and Greek name, and then we give the name of that molecule from the source name. So here I will tell you what are the source name. Look here, we know that, right? Formic acid, the formic acid, the name which is derived from red ant, right? Red ant. So the red ant, the Latin name is formica, means ant. In case of acetic acid, the Latin word is acetum, which means vinegar. Then when it comes to butyric acid, the rancid or butter. The Latin name is butrum, means butter. Clear? So in IUPAC system, aliphatic carboxylic acid are named by replacing ending E. The name of corresponding alkene is oic acid. So numbering the carbon chain, the carboxylic carbon is numbered 1. For naming the compound containing more than one carboxyl group at the time, your alkene name E should be retained. I will explain while giving the name to you. Understand? So we go for next. Look here, the first one, this is your only one carbon, right? So methanoic acid, so ethanoic acid, propanoic acid, butanoic acid. So this name is CH3 COH. So 1 2 3. So 2-methyl propanoic acid. Clear? Next we go for the ethane dioic acid. So in the ethane, E is propane, E is retained, butane, E is retained, E is retained. If it not more than, if it two or more functional group, same functional group exists in your alkene, E name is retained. So this is propane dioic acid, this is butane dioic acid, this is pentane dioic acid, this is hexane dioic acid. So in this first carbon, second carbon, third carbon, all three carbon which we have COH group, so we call it as a tricarboxylic acid. Clear? Next, look here. So now we comes to the benzoic acid. So this is your benzoic acid, benzene carboxylic acid, also we can call it as a benzoic acid. The common name and IUPAC name same in case of your benzoic acid. When it comes to this one, this is acetic acid. In acetic acid there is a presence of or ethanoic acid, the ethanoic acid which has the phenyl group, so 2-phenyl methanoic acid. 2-phenyl ethanoic acid. So second position, that is a phenyl, so 2-phenyl ethanoic acid. When it comes to here, first and the second carbon, so benzene 1,2 dicarboxylic acid. So we will come for the carboxylic acid structure. So look here, this is your CH3 C double bond OH, right? This is your carboxyl carbon. In this carbon we have 3 sigma and 1 pi bond. With 3 sigma 1 pi bond means sp2 iodization. the structure is planar, trigonal planar, the bond angle is 120 degree. Okay, we all know that. Okay, right. Next we go for the IUPAC name of some of the compound which is given here. Okay, so this is first carbon, second and 3. This is propanoic acid, right? In the propanoic acid, in the third carbon there is a phenyl is there. So 3-phenyl propanoic acid. When it comes to this one, I just expand the structure. CH3, CH3, C, double bond, CH, COH. Okay, we should give the number 1, 2, 3, 4. Okay, so 3-methyl but 2-enoic acid. Okay, 3-methyl. Third position there is a methyl. So second position there is a ene. So but 3-methyl but 2-enoic acid. Okay, so when it comes to this one, there is a cyclopentane is there. So this is your function, this is your substituent. Second position there is a methyl is there. So 2-methyl. So this is cyclopentane, right? Cyclopent carboxylic acid. Okay, cyclopent carboxylic acid. Clear, right? When it comes to this one, so 1, 2, 3, 4, 5, 6. Okay, 2, 4, 6 trinitrobenzoic acid. Okay, clear. Next we go for the some methods of preparation. Okay, so as I told you already, if it primary alcohol, okay, in presence of strong oxidizing agent like alkaline KMnO4 or the chromic acid and H2SO4, that we call it as a Jones reagent. That time your primary alkali group which is converted into your carboxylic acid. Okay, clear, right? Go for the preparation. Okay, preparation of your benzoic acid. So the aromatic carboxylic acid can be prepared from vigorous oxidation by alkyl benzene. Okay, alkyl benzene we can say methyl benzene, ethyl benzene, propyl benzene. Okay, so this are all we call it as the alkyl benzene with chromic acid. I already told you chromic acid CrO3 or acidified or alkaline KMnO4. Okay, so chromic acid or alkaline or acidic potassium permanganate. The entire side chain is oxidized to carboxyl group. Okay, irrespective of length of the side chain, the primary and secondary alkyl group are oxidized this manner, while tertiary is not affected because your tertiary carbon not having any hydrogen to undergo the oxidation reaction. Okay, clear. So primary and secondary alkyl. Okay, so your alkyl group having the secondary and primary carbon which is attached with your benzene ring. At the time it is undergo the oxidation reaction, there is a formation of your benzoic acid. Okay, so here there is a methyl benzene, here there is a propyl benzene. In presence of KMnO4 in alkaline medium, this is also alkaline medium. Okay, so this converted into potassium benzoate, right? So this undergo the hydrolysis process, we can get the benzoic acid. Understand? So next we go for the nitrile and amide. Nitrile and amide. So if you are taking the nitrile and amide, okay, so here the nitrile are hydrolyzed to amide. So then to acid in presence of H plus and OH minus as catalyst. So mild reaction condition used to stop the reaction at amide stage. Okay, so we are keeping the mild condition. That is the reason why cyanide which is converted into amide. So how there is a C triple bond N, right? So in this O, in this H2 which can be converted into R C double bond O NH2. Okay, again if I am hydrolyzed, this side OH is added, this side hydrogen is added. So I get the carboxylic acid plus ammonia. Okay, this is the reaction which is occur in here. Okay, so all these places. So next we go for the carboxylic acid preparation by using your Grignard reagent. Okay, so I will write one reaction for you. Look here. See, for example, if I am taking the bromobenzene. Okay, this is your bromobenzene. It react with Mg. What it going to form? Your phenyl magnesium bromide benzene. Magnesium bromide going to be formed. Okay, so we know that, right? This is going to be delta minus, this is going to be delta plus. So metal tends to lose the electron, it is always form the cation. So non-metal, it tends to gain the electron, it is formed the anion. Okay, so plus it react with C double bond O and C double bond O. So this minus going to attack here. So the pi bond move towards the oxygen. This minus going to abstract this Mg. So what is the product it is going to formed? So your benzene, then C double bond O, then O Mg Br. Clear? Then when it react with water, okay, so in acidic medium, okay, so at the time your bond get broken here, okay, so here it get broken, okay, this side hydrogen, this side your OH, okay, so your benzoic acid is the product, and then one more byproduct is this one. Understand? I hope you understand that. Okay, we'll go for next. So look here, the first reaction, which is the from acyl halide, okay, and anhydride, okay, so if it acid react with the acid chloride or acid halide, at the time it going to form the acyl halide. When it from the acid, if you are removing the water, you will get the anhydride, okay, so acid chloride when hydrolyzed with water, give carboxylic acid, are more readily hydrolyzed with aqueous base to give the carboxylate ion, okay, so which anacetate to provide the corresponding carboxylic acid, anhydride on the other hand hydrolyze to corresponding acid with water. Clear? So this acid halide, when we hydrolyze, at the time we will get the acid, but in presence of base, if you are doing, at the time we will get the carboxylate ion. This carboxylate ion further hydrolyzed in order to get the carboxylic acid. So in this reaction, any one reaction I will explain to you. I will take the first one. Look here, CH3, C double bond O, C double bond O, C6H5. Am I right? So if I am doing the breaking here, okay, so this side I am adding the hydrogen, this side I am adding the OH group. So C6H5, C double bond O, OH. So C again, this is also C6H5, C double bond O, OH is there. So two product is formed. So in this also, if you do the this anhydride is formed from the your acetic acid as well as benzoic acid, undergo the dehydration reaction, we will get the benzoic ethanoic anhydride, okay, so we will get the benzoic acid and the ethanoic acid. Clear? So next we go for the ester. So ester, how it formed? In presence of acid catalyst, the acids and your alcohol, okay, so if it undergo the reaction, it will give the fruit smell. It give this fruit smell, that is your ester. So acid hydrolysis of ester gives directly carboxylic acid, while the basic hydrolysis give the carboxylate, okay, so which an acidification gives the corresponding carboxylic acid, okay, so ethyl benzoate, okay, in presence of H3O plus, it give rise to benzoic acid and ethanol, okay. Again, this is also ethyl butanoate, right? So butanoate means, so this is your ester, CH2, C double bond O, ET. Okay, ET means CH2, CH3. So if I do the reaction, so this is this side hydrogen, this side OH. So this become a butanoic acid. So in presence of base, it gives the butanate. Okay, so this is ethanol. Okay, so this is further hydrolyzed, we will get the butanoic acid. Clear? Right. So next we go for there is a reaction. What are the reagent we need to use in order to convert this product? Okay, so it is there in the next page there. Okay, so look here, the first reaction. So this is primary alcohol, right? This primary alcohol oxidizes to acid in presence of strong oxidizing agent, that is Jones reagent. So this is also again primary alcohol, okay, so which can be converted into your benzyl bromide, okay. So this, when it react with KCN, okay, so this KBr get eliminated, okay, we will get the benzyl cyanide, we will get it, okay. Benzyl cyanide again hydrolyze, at the time we will get the phenyl ethanoic acid. Understand? Next we go for the look here, your 3-nitrobromobenzene react with your Mg, it give rise to magnesium bromide. So this magnesium bromide, so this is your positive, this is your negative, this negative carbon attack this carbon, so this pi bond move here, this minus going to obstruct this MgBr, okay. So next step, this side hydrogen, this side OH, so this become an acid, this become a this side hydrogen, this side OH, so MgOH Br, okay, your byproduct is MgOH and Br, okay. So here also we are using the strong oxidizing agent, so this also become a your salt, this also become a your salt. Okay, so this become a potassium benzoate, so dipotassium benzene 1,2 dicarboxylate, so it undergo the acid hydrolysis, it is give rise to benzene 1,4 dicarboxylic acid. Okay, so the next reaction, if I am taking the cyclohexene, this is very important reaction. Okay, because we have to remember it, there is no linkage between other reaction and this one. Okay, so this time whatever the pi bond is there, alkane is there, that carbon get broken, that carbon is which is converted into COH. I already discussed in the 11th standard hydrocarbon chapter. Do watch that video. Okay, so here there is a butanol is there. So butanol, when it react with ammoniacal silver nitrate, this is Talens region, right? It give rise to silver mirror. It give rise to silver precipitate, that is silver mirror. Okay, then how we are going to convert it into your ethyl benzene into your benzoic acid, and acetophenone into benzoic acid. Okay, then your phenyl ethane into phenyl ethane into benzoic acid, bromobenzene to benzoic acid. Okay, bromobenzene to benzoic acid. So if you take your ethyl benzene, so ethyl benzene in presence of KMnO4 and KOH, it gives rise to potassium benzoate. That potassium benzoate, it undergo the hydrolysis reaction, it form the your benzoic acid, your benzoic acid. So I already discussed with you. So this is your ethyl benzene, it undergo the oxidation, it give rise to potassium benzoate. Clear? Then your acetophenone also, when it react with KMnO4 and KOH, your acetophenone also when it react with KMnO4 KOH. So this is your acetophenone when it react with KMnO4, okay, KMnO4 and KOH. Okay, so what it going to give? It is going to give the potassium benzoate. This potassium benzoate react with H3O plus, it give rise to benzoic acid. Okay, so next third reaction it is there. Okay, that is bromobenzene is there, right? Bromobenzene. Okay, so your bromobenzene, this is your bromobenzene, right? So it react with Mg. I already explained this before, some minutes before in this video. Okay, so it give rise to MgBr, it react with CO2, it give rise to your benzoic acid. Clear? So next one, the phenyl ethene is there, right? Your phenyl ethene is there. Your phenyl ethene, when it react with this reaction is new. So phenyl ethene, how it phenyl ethene? This is ethene, right? So in this your phenyl group is there, then we call it as a phenyl ethene. This phenyl ethene, when it react with KMnO4, okay, and the KOH, what it going to give? It is going to give, so here COOK plus HCOOK, breaking is here, this can be converted into COOK, like this reaction. It is there, right? This reaction, like this is the reaction. Again here we are following. Okay, so what is, again we are doing the hydrolysis process, so it can be converted into your benzoic acid, plus this can be converted into your formic acid. Understand? So this is the all about this your carboxylic acid. Okay, any doubt is there, you can ask it in the comment box. Okay, so thank you all, do well in exam.